Hey everyone, it's Matt here with Kojo. So when you start programming, there's a couple of different number systems that it helps to learn. So today we're going to be talking about the fundamentals, the basics of that. We're going to talk about our number system, decimal, and then this will help us understand, or it'll help us as we go through the next couple of videos talking about some different number systems. So hopefully it's not too much of a stretch to understand that language is a code. So different symbols can represent the same concept. So dog in English is perro in Spanish. It's K in Korean, and I don't really even know how to pronounce that in Russian. But all of these things represent the idea of a dog. You can see that obviously they're spelled different, and in the case of Russian and Korean, we don't even have all of those symbols. So yeah, languages have different spellings, definitely different pronunciations, different symbols, like the alphabets of them, different ordering, so left to right or right to left or vertical, different tonal importance, so like Chinese is, I believe, 4 tones, and like Thai is maybe 5 tones, things like that. Additionally, some languages will have sounds that others don't. So when I was learning Korean, there was a couple of sounds that they would emphasize that I could hear it, but it was really hard for me to understand it because we just don't make those sounds. I guess kind of the question is, are numbers encoded? So in a couple of different places I've traveled, the words might be pronounced differently for the numbers. Like the number 5 might be pronounced different in a different language. But usually you'll see that the numbers are written the exact same way. They use the exact same symbols. So the same old 0 through 9, exactly like we use. I guess one question is, how else would we write them? But we should be familiar with Roman numerals. Everyone probably has like a rough understanding of Roman numerals. Even if you don't know exactly how it works, you've probably seen it. So each value, 1, 5, 10, 50, has these different letters. So that's a perfect example of just a different encoding for a number system. So Roman numerals were really good for addition and subtraction. They're really bad for multiplication and division, so I guess that's why we end up not using them. Roman numerals are really difficult to read because the numbers actually grow and shrink. If you compare that with our number system, the decimal system, numbers will grow, but they never really shrink. So as we go from 3, we have 3 symbols. We go to 4, we have 2 symbols. We go to 5, we have 1 symbol. Then we go to 6, we have 2 symbols again. So like that's what I mean. They grow and shrink. It's also difficult to read, partly because we're not familiar with it, but also the order of the number changes the value, and maybe like in kind of unexpected ways. So the number xiv and XVI, the only difference is that one I, and just depending on that position, it changes the number. So decimal is a positional numbering system. That's what it's called. The numbers grow slowly and they never shrink. And each position of the digit changes the value of that number. So we're decimal, so we call that base 10. So if we look at the number 6,234, we know that it's 6,000 plus 200 plus 30 plus 4. So a different way to look at it is 6 times 1,000 plus 2 times 100 plus 3 times 10 plus 4 times 1. Or another way to look at it is 6 times 10 to the 3, 2 times 10 to the 2, 3 times 10 to the 1, 4 times 10 to the 0, because anything to the 0 power is 1. And so that's really how our number positioning works, or our positional number systems work. That's how our decimal system works. Decimal just means base 10. And so it's base 10 because, again, each new position is an increasing power of 10. So, like I said, we're base 10. Each position is a power of 10. We also have 10 unique symbols. So the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have 10 symbols. After 9, we just start reusing the symbols, and we add a position. Okay, so 9 plus 1 is 10. We have a different word for it, but we're really just reusing those same digits. Now we're saying this is back to 0. and we add a new position and we add 1 there. Okay, and so the system works with fractional values as well. So after the decimal place, we're just counting down. So this is 10 to the -1. This is 10 to the -2, and so on. Anything in front of the decimal place is, again, increasing powers of 10. So 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, and so on. Addition is really easy because we're always just adding like single-digit numbers. So as we go through our positions, right? Like, again, this is all pretty basic. It's all things we all learned in elementary school, but we're going to see these same kind of charts in different numbering systems. So yeah, addition is easy, right? We're just adding pairs of single-digit numbers, and we just follow this chart right here. Usually easier than that because we've just memorized all of this. Multiplication is also easier, or is also easy. The numbers get bigger faster, but still, it's just pairs of numbers, and we just kind of memorize this. One question people ask is, why base 10? It's arbitrary, meaning it didn't have to be base 10, and it doesn't have to be base 10. Probably, some people say it's probably because we have 10 fingers and 10 toes, so humans are really good at counting to 10. Although I think I remember the Mayan numbering system was base 20. I learned that a while ago, but I'm pretty sure that's how it goes. So it's not just that all humans forever have always used base 10. The interesting thing about this is we can have this positional numbering system to other bases as well. So if we were talking about Mickey Mouse or Homer Simpson, they would be really good at counting to 8 because they have 4 fingers on each hand. So what would that look like? I guess that's kind of leading into the next video. So we're going to see exactly what that looks like. We'll see you in that next video.